In this lesson, we're going to take a look at right angle trigonometry, and we're going to look at trigonometric identities. To do this, we're going to understand angle-side relationships, and we're going to also review the trigonometric identities. So, in a right triangle, we have three main sides. We have two legs, and we have the longest side, which is called the hypotenuse. And the adjacent side is relative to the angle in question. So for example, if I'm using this angle x, let's call this, so this is angle x right here. If I'm using this angle, the hypotenuse never changes. It's the longest side here. So I'm going to call this hype right here. But then the adjacent side is the side that forms the angle with the hypotenuse. So if I label this triangle A, B, C. So with respect to angle X, the adjacent side is BC. So let's look at this. Let's call this angle X. Adjacent is going to be BC. And then the opposite here would be the side that is not involved in forming that angle. So we can see here that the opposite in this case is going to be AB. Now let's apply the same to angle Y. So with angle Y, the adjacent is that side that forms that angle with the hypotenuse, which is going to be AB. So adjacent is AB. And then the opposite is the side that is not involved in forming the angle, which is BC. So the sine of an angle of a right triangle is represented as the opposite side divided by the hypotenuse. So let's look at this right here. What is the sine of angle X? So we're told that is the opposite, which is 8, divided by the hypotenuse, which is 10, which is going to be 4/5. And then sine Y, the opposite to Y is 6, the hypotenuse is 10, which is 3/5. So the cosine of the angle is giving us the ratio of the adjacent side to the hypotenuse. So in this right triangle here, the cosine of X is going to be the adjacent, which is 6, over the hypotenuse, which is 10, which is going to be 3/5. The cosine of Y is adjacent. Remember, the adjacent side is the side that forms that angle with the hypotenuse. So that's going to give 8, and the hypotenuse is 10, which is going to give you 4/5. Now let's look at the tangent. The tangent has no ratio with the hypotenuse. So the tangent is the opposite side divided by the adjacent side, or the ratio of the opposite side to the adjacent side. So let's look at tangent of X is opposite, which is 8, divided by the adjacent, which is 6. This gives us 4/3. And then tan Y is the opposite, which is 6, divided by the adjacent, which is 8. This is going to give us 3/4. So this is seen as TOA. So when you bring it all together, you have what we call SO, which is sine opposite of a hypotenuse, Ka, which represents cosine adjacent of a hypotenuse, and then TOA, tangent opposite of an adjacent. Now what we're going to do here is we're going to try to find the values of the missing sides and angles. Let's start with X. Because this is a right triangle, what we know about triangles is all angles in a triangle equal to 180 degrees. So the angle formed at B is 90 degrees. So 90 degrees plus x plus 30 degrees is equal to 180 degrees. So 120 degrees plus x equal to 180 degrees. Let's subtract 120 degrees from both sides. And x is 60 degrees. Now, we're going to look at 30. Sine 30 is opposite, which is z, divided by hypotenuse, which is 13. Sine 30 is 1/2 is equal to z over 13. Let's take a cross product. So 2z equal to 13, divide by 2, divide by 2. Z is equal to 6.5. Now, let's look at the cosine of 30. That's going to give us the square root of 3 over 2. So, but cosine of that angle with 30 is adjacent, which is y over hypotenuse, which is 13. So, square root of 3 over 2 is going to be y over 13. So, we're going to take a cross product. 2y is equal to 13 square root of 3, and y, you divide 2y by 2, you get y equal to 13 square root of 3 divided by 2. And so that's how we find the values of x, y, and z.